Hello and welcome to the video tutorial for graphics programming level 1. In this tutorial I will show you how to set up a project in Visual Studio 2012 that you can use to quickly create an OpenGL demo. So this tutorial is based on the article written on 3dgameengineprogramming.com or 3dgep.com titled Introduction to OpenGL for Game Programmers. So if you want to follow along, the link to this article will be in the description below. Okay, so as you can see, I already have Visual Studio 2012 open, and I'm going to create a new solution to store our OpenGL template. And we can use one of the existing templates for our new project, but I prefer to start with a fresh, empty project template so that I create everything else myself. So the first thing we want to do is we want to specify a location where our templates or our projects will exist, and I already have a directory here called projects, so I'm going to choose this folder here, and I want to create a directory for my solution, so I have that checked. And my solution is going to be called OpenGL, but my project is going to be called, I'm going to call that OpenGL template. And this will be a project template that I can copy, paste, basically just duplicate it in my directory to create new demos quickly. All right, we'll create that. Now what Visual Studio will generate is the solution file as well as the project file. And if you look in the Explorer, we can show this in the Explorer view, and you see that we have a solution file, and we have inside that we have a directory for the template itself. Now I like to split my source files and my include files into different directories. For source, I usually create a directory called source, and for my include files I'll create a folder called inc. So when we create these files, we'll specify these directories to place them in. Another thing that I want to do right now is I already know that I'm going to be using a lot of external libraries, a lot of third-party libraries in order to facilitate rapid development here on this OpenGL solution. So I'm going to create a directory already at this point called externals, where I'll keep all the externals that I'll be using, not only in the OpenGL template, but in any new project that I create within the solution. Later on, we'll be doing OpenGL extensions, and I'll be using these externals as well there. So we'll just create a directory there. Okay, so the first thing I want to do is in my project over here, I'm going to create a new solution, a new source file. So for that, I can just create a new item. By default, it has that CPP file selected, and that's exactly what I want. I want a main CPP file. But since it's a CPP file, a source file, I want to put it in the source directory. So I'll select the source directory, and I'll call that main. And we don't need to supply an extension because Visual Studio already knows we want to create a main.cpp file. So this is basically going to be our main entry point for our application. So usually we include some of our default libraries, such as standard lib, C standard lib. That's one that we generally use a lot. We also want to make sure that we also include IOStream for writing out to the console window, and we also want to include a library called, it's hard to type and talk at the same time, ctime. Ctime includes some kind of header files for keeping track of the elapsed time. We can also create a high resolution timer, but for our purposes we are just going to use the system clock basically. So our entry point should look like this. Int arg count and char star arg v. So basically this is an argument array. And if you haven't done any C or C++ programming in the past, basically this variable tells you that the number of parameters that are being passed here, and this array here, this char array will be filled in with the command line switches basically that are used to start the application, as well as the name of the application. We're not going to use command line switches for this demo, but we're still going to use this entry point function. So in order to see that if it's working, I usually just do this. I have the system function here, and we just pause. This will allow us to test to see if at least the application builds, and we see that it's building and it's putting the executable in the debug folder. And now if you run this, we should just see a console window with just press any key to continue. So that's great. Now I know that this is working, and I can continue from there. I know that all my project settings are pretty much correct. I don't need to change anything for this. Okay, but we're going to be using OpenGL for this, so obviously we want more than just a console window. There's many ways you can create a rendering window for OpenGL, but I don't feel like rewriting a lot of boilerplate code. So I'm going to be using a third-party library called FreeGlut to generate my window and do things like swapping the OpenGL back buffer and presenting the display onto the screen. So there's multiple options. You can use OpenGL template libraries. You can use GLaDOS, which is the old version, and FreeGlut. I prefer to use FreeGlut because, well, one, it's open source, so all the source code is provided, where GLaDOS is closed source. And it's got some enhancements that GLaDOS didn't have. So I'm going to download FreeGlut, and then we're going to install FreeGlut into the directories we created. So FreeGlut, which I already had on screen there for a second there. So FreeGlut is an open source project, so it's on SourceForge. And the latest one is 2.8.0, which was released in January 2012, which over a year ago, slightly more than a year ago, but at least it's, you know, newer than GLaDOS. GLaDOS has been out of development for a long time. So if we try to open this, it says, yeah, it's a tar file. Do you want to open it? Yeah, let's open that. And then WinZip will give us the internals. So basically, I want to extract everything in this directory to my externals. So let's unzip that, and we'll put that in our projects and in OpenGL externals. So we'll unzip everything to there. Okay, so now if we look in here, we see we've got a bunch of, well, the include files in here. There's not too many of them. And the compiled libraries, but it also comes with Visual Studio 2010 solution file and project file, which we can actually use directly in our Visual Studio 2012 solution. So that's what I'm going to do. I'm going to actually add the existing project from that Visual Studio directory here, 2010. So yeah, he gives me a warning that it was not created on this computer, so he says, do you trust this source? Yeah, I trust this source. So that's FreeGlut, and we've already just included that, but we still need to tell our project how to find the include file, so we'll do that in a second. The second dependency I'm going to use here is for extensions. Now, extensions I won't go into detail in this tutorial, but I will go into further depth in a later tutorial. So for that, I'm going to use Glue, the OpenGL extension wrangler library. Now this is still in development. You can see that the latest release was in either August or, yeah, I think that was August 6, 2012 at version 1.90. Adds extensions for OpenGL 4.3. Here's where it was. I want to get the source package because I'm just going to include the solutions directly into my project and have Visual Studio automatically build Glue. Okay, so we see that the Glue 1.90 extension here. We'll just drag that into our into our externals folder here, and WinZip should extract everything there. Right, so now we got glue, and again we have an include folder which doesn't contain much, and the source code, which basically just wrapping the OpenGL extensions. So those are the two things that I'm going to use in this. And again, glue also contains a Visual Studio 2010 solution file and project files for Visual Studio 2010. But I can directly include these into Visual Studio 2012 by going add existing project, and we'll go back to our externals, glue, build, VC10, and I want the static libraries. So there's different builds for different tools. So there's a few tools that glue provides, but I'm only interested in the static libraries. Again, Visual Studio warns me that this is an external project. So we include the static, and that will automatically build. So we can build that. It will automatically build the static, in this case debug, the last letter D represents the debug build. And I can then link against this library for my application, and I do not require a dynamic DLL. I can just link statically, and then I have less to distribute. All right, so but another thing is these solutions, these project files, they come with a large number of build configurations. Now, I think this is quite messy, so one of the things I like to do is I like to narrow it down. So we go into the configuration manager, and we want to edit the configurations, and I'm going to just remove all of the configurations that I don't want to see. So remove that one, and we'll remove that one, and we'll remove that one. So now I'm just down to debug and release. But you see that if I switch to those, then you get different build configurations depending on whether you're building debug or release. But for FreeGlut, again, I also want the static library. So I want to specify that if I want to build the debug, I want FreeGlut to use the debug static configuration. And same thing in release. I want to make sure that FreeGlut builds the release static version of the libraries. Now glue static will already be static, so I don't need to change that to anything other than the default settings here. So that's okay. Now, in order for OpenGL to make sure that it builds the right order, for this thing to build in the right order, I have to specify the project dependencies here. So if I say that the OpenGL template is dependent on both these libraries, I'll make sure that the FreeGlut, these are built now in this order. So sometimes when you build your project, it says can't link against this library, and then you have to manually go build them. But if you specify the project dependencies here, then Visual Studio will make sure that everything is compiled in the right order for you, so that dependencies are linked correctly. Okay, so now that I have these in my Visual Studio project, I can tell Visual Studio that I want to make sure that he knows where to find the include folders for both the glue and the FreeGlut. So in order to do that, I have to specify the additional include directories. Now, he doesn't automatically know about these, so I have to specify these paths manually. So I'll do that here. And sometimes it's difficult to know how you specify these paths. I would not use this method simply because what it does is it will include this path with a absolute path. Now that's not in any way ideal, because if I want to distribute this project and somebody else has these files on another directory other than D drive projects OpenGL, it's not going to work for them. So I want to specify the include paths relative to the project. So if I go to this project here, I'll do the second independent include later. I can open this folder in the File Explorer and see exactly where it is. So all the files, all the settings you specify in the project are going to be relative to this file. So I know if I go back one directory and then I go to externals and then include, that's where it's going to be. And if I copy my entire solution from this point, I know that all my dependencies and all my references will be correct because they're all relative to the project files. So let's go back in there. back into the properties. And let's edit this again. So I've got FreeGlut, and I'm also need the glue include directory here. So I want to include that one, but then again I want to make sure that I don't do anything silly. I don't want to include any absolute paths in my include directories. Okay, now these settings are the same for both debug and release. So what I recommend you do is, instead of just changing for one configuration type, specify all configurations. We'll save that. And we'll just paste the options there. So now both the debug and release, save them, are going to be using these paths. Now you might want to specify different paths for the library directories, but we'll get to that in a second. Okay, now with that specified, I can include my header files that I'm going to need. So for glue, I'm going to need to include GL glue.h. Now we might not resolve this automatically, but if you can right click on it and open this and the path shows up correctly, then you know that your compiler will be able to resolve this path. Now you might be wondering why I used angle brackets instead of quotations. Well, this is not just a personal preference of mine, but these angle brackets specify to the compiler to first search external paths. In other words, paths that were specified in the project settings here. And if it can't resolve a file name in the external paths, it will then look relative to the file itself. Whereas if I did this, it will still work, but the search paths will first search the location relative to this file if I use the double quote notation for including. So this is also communicative. It specifies to me that this is not relative to this file, but relative to the include paths of the project. So that's good to know. Another thing I want to include is the FreeGlut header file. Now, if I compile now, it'll compile all my statics and things like that. But it tries to automatically link against this library. So if I go into here, I see that in the standard header file here, you see that this is a specification specifies that this is actually relative to this file, so in the same folder. So that's a good rule. So you see that if I what happens is that it tries to automatically link using this hash pragma. So, but it can't find this file yet, even though well, actually it compiled the static version. So I wanted to specify this hash define in order to specify that you must actually load this library. So instead of just doing that, I'll just hash define this out here, FreeGlut static, and that tells FreeGlut to load the static version of the library. However, it still won't be able to find the static version of the library. So now you see it's trying to link against the static library. Well, this is because I haven't specified where to look for these particular files. So I need to tell Visual Studio again where to look for the libraries. So in this case, I want to go to the linker, and I need to specify additional, I always forget, additional library directories is here in Visual Studio 2012. I think it was on the input before, but again, I'm not sure. But even though I specified link library dependencies as yes, it still doesn't link against the dependencies that were built with these projects. And I'm not exactly sure why, but in order to resolve this, we can just specify the path to the compiled libraries. So for FreeGlut, these go, I believe they go into lib. Let me just check that. Make sure they're, again, relative, not absolute. We can check the paths by clicking on here, and under configuration it has them in lib x86. So then in that case I know that that additional library directory is correct for release builds. But it actually uses a different path. So if we look in here, it's going to put them in x86 debug. So for OpenGL debug version, I want to make sure that he links against the other directory, which doesn't exist yet. Let me just build that. So now you see that the output is here in FreeGlut static lib. Okay, so let's now tell him that during debug builds, I want you to additional library directory, and we specify externals FreeGlut lib x86 debug for debug builds. And again, I want to make sure that these paths are relative to my project folder and not absolute. All right, so now that I have that path specified in my additional library directories for both debug and release, you can see it builds now. Okay, so now that we have our header files being included and we have our library files, let's start writing some useful code. So the first thing I'm going to do is I want to initialize GLaDOS. I want to create a render window, and basically I want to start rendering stuff. So there's a few things we need to know. For starters, I want to know how big the window should be. So I'm just going to create a global parameter for window width, and I'm going to initialize that to 800, and window height 600. It's a pretty small resolution, but for this purpose, for my purpose of this demo, I don't really need a big render window. And another thing I'm going to need is a window handle from GLaDOS. So we'll call that window handle, and we'll initialize that to 0. So when we create a window, GLaDOS will give us a window ID, basically, which allows us to uniquely identify the window that was created. In GLaDOS, you can actually create as many windows as you want, floating windows, and each window will be uniquely identified by its ID. Okay, so, and I'm also going to create a function to initialize GLaDOS. So we're going to init GLaDOS. We might want to change this later. So I'll just declare a prototype or a declaration for that function, and then I'll call it in my main function. So let's now define the function init GLaDOS. And one of the things that GLaDOS needs to initialize is actually the argument count and the argument array. So I'm going to pass those as parameters, which will just give it basically the same signature as the main entry point. So I'm going to have to update my prototype, these arguments. Of course, hit control copy instead of control paste. And I have to pass the arguments, just like so. Now, to initialize GLaDOS, there's an initialize function called GLaDOS init, which, like I said before, takes the argument count basically as a pointer. So I want to pass the address of the argument count. I don't know why pointers should not be modified in this function, but maybe it is. And the argument array argv. It's already a pointer, so I don't have to specify that it should be a pointer. And if GLaDOS initializes properly, and I'm not sure, but I think that it doesn't return an error code. So basically, if it causes an exception, perhaps it won't work. But I've never seen it not work before. So now we're going to specify. I'm going to specify an option that when GLaDOS is finished, I don't want it to kill my application directly, but instead I want it to actually return processing back to the main function so I can do other things such as clean up any resources that I may have allocated. You can also set a callback handler that gets invoked when GLaDOS is quit, but I prefer this method because You might want to return an error code from here if something happens, or it's just much cleaner. So we'll call action on window close, and we want to specify that the GLUT action continue execution, basically, which basically says that after you start the GLUT main loop, I want you to come back to the main function, which we'll do that in a second here. But let's finish that. Okay, so we set that option, and we also are going to initialize our window. So to do that, we're going to get the screen height, and we can use GLUT get for that. There we go, thank you. And we also want to get the screen height. One thing that's useful is actually, I know the parameter I want is GLUT screen height, and Visual Assist, which I'm using Visual Assist for basically for helping me code, will automatically fill in the parameter there. That's quite nice to know. So we also want to initialize the screen mode, or the display mode, sorry, with GLUT RGBA, which basically says that I want to have a red, green, blue, alpha color buffer for drawing to. And I also want to specify GLUT alpha, which says create an alpha channel, and GLUT double, which specifies I want this double buffered. Double buffering provides, prevents basically screen tearing. So if you are trying to refresh the screen between vsync refreshes, you don't get what's called screen tearing. You can look that up if you want. And I want to also make sure I have a depth buffer. If I don't specify a depth buffer, then things will not be rendered correctly. I can show you what happens if you don't specify that, but you can also try it for yourself. Basically, nothing gets drawn in the right order, or you'll get tracers, basically. Okay, I also want to initialize the window position. So in GLaDOS, before we create the window, we have to initialize the window position. So I know the size of my screen, and I know the size of my window, so I can specify that it should be the screen width minus the global window width, and divided by 2. Now this is an integer, so I don't think that will do any good. So I'll just keep it as an integer. And for the width, screen height, minus the window height divided by 2. Now this makes sure that my window is always initializing in the center of my screen instead of in some random position. Now that just initialized the position, but I also need to initialize the window size, and that'll be the window width and the window height. Those two parameters. And now I've done pretty much everything I need to do to create the window. So window handle, it's a handle, so window handle, GLUT create window, and you can specify a name, and we'll call this OpenGL template. Okay, now if I run this, it won't really do anything because we still have to tell GLUT to start the update loop. So in order to do that, GLUT main loop. This function will kick off the main loop, and execution will not return back to this function until it's done. So now if we run this, we should get a render window with absolutely nothing drawn into it, because we don't have a display function yet, so we still need to tell him what to render in this window. And if I close it, then as you can see, it goes back to the main function, and I can just kill it. So we'll get rid of that. Now if I close the main window, the render window, the application just closes. Okay, so the next thing I want to do is I want to specify some functions that get invoked when something happens, like uh, GLaDOS has to display the window. So let's do that first. Display GL. I also know now that I also will have an idle function, so I'll have idle GL. And this is a personal preference, but I just postfix these with GL just to indicate that these are callback functions from GLUT, basically. And GLUT also has keyboard callback functions, so we have keyboard GL, which takes an unsigned char and an X and a Y for the current mouse position when the key was pressed. We also have mouse GL callback, which takes button state and the button that was pressed, so 0, 1, or 2, the state, I think 0, 1 for up or down, and the X and the Y. So this function we'll use for detecting when a mouse button was pressed or when a mouse button is released. And we also can detect when the mouse has moved. So this is basically the passive mouse function that will get called every time the mouse moves anywhere on our screen. For this particular demo, we're not going to use these functions, but I'm going to define them in the template so that I don't have to redeclare them if I create a new demo. And we also have a callback function that gets invoked when the window is resized, which takes two parameters, the width and the height of the window. Okay. So that's good enough for now. Now we need to register these callbacks with GLUT. So the way we do that is we tell it that which callback functions we're going to use. So the code display function is going to take display GL. And basically it expects a function pointer. So just passing the function name like this to the callback is sufficient to tell them to invoke this function whenever the display needs to be shown or redrawn. And there's also the idle func, which idle GL, and keyboard callback function, keyboard GL, get rid of that, and GLUT mouse func from mouse GL, get rid of the, and GLUT motion func, get rid of that, and the reshape. So now if we compile this at this moment, we'll actually get some linker errors because these functions don't exist yet. I'm using them, but I haven't actually defined them yet. So I'm just going to copy the function definitions down here. And I'm just going to define stubs for these now. They don't do anything, but at least the program will already compile. This is similar to test-driven development, I suppose, where you stub something out and then you fill it in later and check to see if it's actually still working. So now if I compile, it should give me no errors. It does give me a warning, and you might see this actually quite often. And this happens when you link against a library that is compiled with a different version of the library. So we can tell our executable to not link against that library because it's already been linked into one of these other libraries. So let's just go into our linker settings, and in the input settings we can ignore specific default libraries, and in this case I want to ignore libcmtd. Okay, so if we do that and I build that again, you see that now the warning is gone and we've successfully built our application. Okay, so that's pretty okay for now. We've got a display function that gets called, we've got an idle function, we've got a keyboard function. I want to actually do something if the keyboard's being pressed, but one of the things that I find difficult to know is which key code is being called when I hit a key on the keyboard. So what I'll do is I'll just actually use the stdcout command to print the character code as an integer to the screen. So I'll just actually prepend this with something so I know what I'm talking about. Key pressed. So now if I run this program and I hit keys on the keyboard, you can actually see what button. So if I press escape here or the space bar, I can see that escape is 27 and space is 32. So if I switch on the character code, I can specify that if I hit 27, I want to glut. I want to kill the main loop basically. So to do that, I use glut leave main loop. Leave main loop and break. So now if I run the program again and I hit escape, the window closes. So that's good. That's kind of helpful. You can add some more switches. For example, I want to do something if 1 was pressed, or if 2 was pressed. And we'll fill these in later, but I'm just gonna kind of show you how we can handle keyboard input in GLaDOS functions. Okay, so this is pretty much the absolute minimum program that you need in order to get OpenGL up and going on your graphics card and creating a display window and showing it on the screen, but it doesn't really do anything. So let's get it to do something. Let's get it to show a cube. I'm going to keep this as simple as possible because I don't want to get it too complex. I've already kind of got something drawing in immediate mode. I'm just going to copy paste this because a lot of the code typing is really redundant. I'll go through the code here. So basically when we start the display function, we want to make sure that we're in the right matrix mode. So we switch to GL model view. There's actually, I think in OpenGL 3 or 4 different matrix modes. There's model view, there's projection, there's I think there's a texture matrix mode and other things. These are all basically, these are deprecated as of OpenGL 3.0. After OpenGL 3.0 you have to use your own matrices, but like I said, I want to keep this as simple as possible, so I'm going to use immediate mode and some deprecated features of OpenGL. Okay, so basically what this is doing is loading the identity. The model view matrix will be set back to identity. Then we want to translate, basically, we want to translate our world backwards 6 units so that we can see what it is we're rendering. Actually, I'm going to get rid of this first, and then we'll see how this looks without translating. And I'm going to do this because I want you to see the error that occurs, so that if it happens to yourself, you'll know why. Okay, there's a global rotation parameter here, so let's go fill that in. That was in my previous demo that I had yet transferred over. So we have a global float rotation. What was it called? Rotation. Rotate 1. So let's just define that, and we'll initialize it to 0.0f floating point value. We're not updating this, so let's actually do that. One thing I didn't do yet, I don't have my counters. So in order to get this to update independent of the frame rate, I'm going to use delta time calculations to make sure that my rate of rotation is specific or relative to the amount of time that is passed. So let's make a rotation rate parameter. And let's set that to, I don't know, say 50. And this will be in degrees per second. All right, so there's this idle function which I've registered with glut idle function, and basically the idle function will be called whenever glut has nothing else better to do. So here's the callback entry point, and what we need are two tick parameters. I keep forgetting these. So I need the previous tick and I need to know the current tick. So those two parameters will be integers as well, I believe. This is not a high resolution timer. If it was, I'd probably be using double precision values. But we're just gonna actually, sorry, they're clock values, clock t. So g previous ticks and g current ticks. Now we'll convert these to seconds later. And if you're wondering where the hell this clock t comes from, well, that's what the ctime library provides us. So we've got those, and we need to initialize the first one just before the main loop starts. So g previous ticks is equal to clock. So this function is a static function declared in the std namespace, which basically will just create a clock structure, which I can use directly. And this says get the clock time at the current time. So right now. And then in my idle function, I'm going to query the current ticks with the same method, clock. And now I need to calculate the difference between the previous ticks and the current ticks. So that's going to end up being a float delta ticks current ticks minus the previous ticks. So what this does, it basically gives us the number of ticks that has occurred since my application started and since this idle function was called again. So in order for us to continue this, I need to store the previous ticks from the current tick. So next time we come back in here, we'll get the delta from this point till the next time the idle function was called. And now we need to convert that into time. So we take the number of ticks that we counted, and there's this clocks per second, which is something like 1,000, which will allow us to convert this into the amount of time that's passed in seconds. Okay, and now we want to update our rotation parameter, rotate 1. We'll just add to that the rotation rate times, get rid of all that, the delta time. So now we have a rotating primitive that is based on the amount of time that's passed and not on the number of frames that's passed. This is really important if you want to try to achieve constant rotation rates no matter where your application is being run. And we also want to make sure that if, for example, we end up running this program for, I don't know, 6 to 12 hours, that we don't get integer overflow. So in order to do that, we can clamp our time. You might argue that this is quite an expensive function, but you'll see that the overhead is quite minimal. You might want to use an if statement. If it's greater than 360, then subtract 360 from it until it is less than 360, but whatever. This does the same thing except for in one line of code. All right, and we also want to tell GLaDOS to post redisplay. Now what this does is just says, GLaDOS, I want you to display the window the next convenient time. Without this post redisplay function, the window will never be redrawn. So usually we put this at the end of the idle function or the end of a keyboard function, or if the mouse moves and it updates something, then we want to redo it. Or if the window is reshaped, we want to also make sure that you post the redisplay. Otherwise, nothing gets shown. Okay, so we're not using that rotation yet, so let's put it to good use. Oh, sorry, actually we are using it. I've already filled it in here. So let's just see what we get. Now you might be surprised to see that we still get absolutely nothing. Well, this is not actually that surprising at all because we still haven't told OpenGL to clear anything. So we need to make sure that we clear the color buffer bit and the depth buffer bit. This tells OpenGL to clear the two buffers, the color and the depth buffers, which are being used to render our image. If we don't clear these, well, I can leave these here, then we'll end up just drawing over top of the last frame, which will generate some weird results. The other thing we have to make sure we do is to swap buffers and post redisplay. Now, post redisplay may not be entirely necessary because we're already doing that in the idle function, and it's kind of an optimization not to do it because if nothing changes, then we're not going to redraw. So let's see what happens now. So this is quite fascinating. We get this nice, fancy, looks like a test pattern or something. That's obviously not what we wanted, so let's try to figure out what's going wrong here. Well, the first thing is, well, we didn't clear the depth buffer and the back buffers, so doing that still doesn't give us the right results. So what could be wrong? Now, this is something you might see in your own programs. Even if we push the camera back, well, yeah, now we don't get anything. But what we haven't done yet is we haven't set anything up to tell OpenGL what the projection should look like. So basically, we need to specify a camera. So to do that, we're going to specify that in the reshape function. The reshape function will be called the first time the window is displayed, but it also will be called every time the window is resized. So I have some boilerplate code here, which I'm just going to copy paste into this function. So basically, I want to make sure that the height is not 0. If it's 0, then we're going to have a problem when we try to calculate the aspect ratio here. We'll get a divide by 0 error. So I want to make sure that if it's 0, I want to at least make it 1 so that it won't give a divide by 0 error here. So the next thing I need to do is to size the viewport. I need to tell OpenGL that my viewport window is going to start from the top left-hand side of the screen, that's at 0, 0, and it's going to be this wide and this tall. You can specify split screen display mode by changing these parameters. So you can actually say, I only want to render to the first quarter of the screen. This is where it's done, the viewport. So if your image is not being displayed on full screen, make sure you specify a viewport. The next thing we want to do is we want to set up a projection matrix. OpenGL, or the OpenGL utility functions, provide a perspective function. You also have different functions for orthographic, for example, ortho 2D, or other types of perspective matrices, projection matrices. But in this case, I want to specify a perspective matrix. The first parameter specifies my field of view, and I believe that is in the, it says Y, so it's a horizontal field of view, so how wide the camera is along the horizontal plane. The aspect ratio, which is almost going to be width divided by height, 99.9% of the time. We also want to specify the near plane and the far plane. So things closer than this to the camera will be clipped, and things further away from this will be clipped away. And I want to also specify that if the window is resized, I want to make sure that I redisplay the window. So now let's see what happens if we run again. So now we get the cube rotating at a really high rate, but it's also not drawing correctly. But one thing I am not doing right is I'm not telling OpenGL to actually use depth test. So in the init function, I'm going to specify that GL enable GL depth test. So with depth test on, you'll see that OpenGL will actually use the depth buffer to draw the cube. So I made a silly mistake here why this cube seems to be rotating so fast. I actually didn't want to increment the fmod function. So now if I run it again, you see it's rotating at a rate of 50 degrees per second correctly. Okay, so that's actually about it. There's a few other things you can do to improve this function or for this demo. For example, you could pause the animation when the space bar is pressed. Well, let's do that actually. Let's create a Boolean. G is paused. Make sure it's initialized to false. And if we press space on the keyboard, case space, we're going to say G is paused. Basically, this toggles. Also do that. This toggles the pause state, and in my idle function, if it's not paused, then I don't. Then I want to update my rotation. So now if I hit the space bar, I can pause the animation. That pretty much sums up this tutorial. In the next tutorial, I'll go over OpenGL extensions and we'll talk about vertex buffer objects, and we'll see how we can eliminate the overhead of using immediate mode rendering by creating a vertex buffer and storing the actual vertices of my model on the GPU. That significantly increases performance because using immediate mode you have to send the vertex information, the vertex attributes basically every single frame, and that's really not ideal. Okay, that concludes this tutorial. And in the next tutorial I'll show you extensions, and we'll actually put the glue header file to good use. Today it wasn't really used, but it's good to have it in the demo in our template, because then we don't have to keep including it. And we'll create a function for it in the next demo, which will initialize our extensions, and then we can use some extended features of OpenGL. Okay, thanks for watching.